Ladies and gentlemen, it is I, Coach Gu, back with another fun-filled, action-packed, non-flipped Algebra 2 classroom video. Today, Unit 3, Notes number 3, and it's going to be all about our final topic before our Unit 3 test, solving absolute value inequalities. All right, first, remember, the absolute value of x is the distance from 0 to x on the number line. All right. Now, if that's true, then the absolute value of x less than p means that x is less than p units away from 0. So let's actually draw this out on a number line to see what it really means. So remember, it is less than p units away from 0. So let's put 0 right here. Okay, and then let's say we're p units away from 0. So p units away from 0, I'm just going to make it up right here. And I'm using an open circle because I don't see an equals to on my less than symbol. Okay, so and then p units away in the opposite direction. Let's just say it's right there. Okay, both of these need to be the same amount of distance. That's p units. That's p units. P units in the positive direction would mean this point is actually positive p. And in the negative direction, this point would be negative p. All right, so if x has to be a number that is less than p units away from 0, where are my possible solutions going to be? My possible solutions are going to be on the inside, in between both of these points, p and negative p, because x has to be less than p units away. If I said that the answers were out here, that would be greater than p units away. All right. Okay, so now that we've seen the visual, we're going to write an inequality that tells us what the possible values of x are. So what is the lowest possible value of x here? It's going to be negative p, and then we have a less than sign because that's what we had in the original equation, and it's an open circle. And then remember, x is going to go in the middle, and x has to be less than, what's the greatest number it can be? Positive p. Okay, and if we're going to write this out into an expression with words, the way we'd write this is x is greater than negative p and, let me put this in caps, this is very important, this is an and situation, and x is less than positive p over here. Alright, so let's take a look at how we're actually going to solve absolute value inequalities and how we would graph our solutions. So, to solve a less than absolute value inequality, we're going to rewrite the equation as a compound inequality where the solution is between the positive and the negative. So what does that look like? Remember, just now we had that negative p is less than x, which is less than p. This is the form that my answer is going to look like. And make sure you understand that with the less than, when we're solving less than, this is an and situation. So somewhere around here, write and. This is an and situation. Okay, so let's see what we're going to write here. Okay, we see this first one says absolute value of 2x minus 1 is less than 5. We want to make an absolute value inequality in this form over here. So what we're going to do is write greater than on the left side and then put the negative version of what's on the right side. So negative 5. All right. And so now we can take the absolute value bars off. Let me rewrite my whole equation. Negative 5 is less than 2x minus 1, which is less than 5. So if I'm going to solve for x, what do I need to do first? I'm going to add 1. Hold on. This time we've got terms on the right and the left. So whatever we do in the middle, we're going to do to all the sides. So we're going to add 1 to all the sides. Plus 1 plus 1. What is negative 5 plus 1? That's going to be negative 4. Then we have less than. And this 1 is canceled. Oh, my throat. 2x less than. What is 5 plus 1? That's 6. All right, now I need to do one more step to get my x by itself. So I'm going to divide by 2. Divide by 2, divide by 2. What is negative 4 divided by 2? That's negative 2. Less than, we cancel out the 2. X, which is less than 6 divided by 2, is 3. So we can see here my answer is negative 2 less than x, which is less than 3. So let's graph what that looks like on the number line. So look at my lowest number. That's a negative 2. So let's go ahead and put 0 right here. And then negative 2. So 1, 2. Negative 2 is right here. Negative 1's right there. And are we going to use an open circle or a closed circle? Notice it's a less than. There's no equal to, which means we're going to be using an open circle. This means that our point doesn't actually include negative 2. It's everything above that. Okay, and then where's our next point? It's at 3. So that's going to be 1, 2, 3 right here. And what symbol should we use? We see that there's no equal to, so we're going to use an open circle. So 3, and then 1 and 2. Now what I'm saying about this being an AND solution is that your solution is supposed to be greater than negative 2 and less than negative 3. Where would that be on this number line? That's going to be in between these 2 points. So we're just going to shade like this. And that's how you would graph your answer. All right, let's do this next one over here. First things first, we can't have these random numbers on the left side. We want to get the absolute value by itself. So what are we going to do? We're going to add 5 to both sides. So if I add 5 to both sides, that's going to leave me with 2 times the absolute value of 4x plus 1 is less than or equal to 1 plus 5 is 6. All right, but I still have this pesky little 2 on the left side. I'm going to divide everything by 2. And that's going to leave me with absolute value of 4x plus 1 is less than or equal to what's 6 divided by 2? That's 3. And now I'm going to be working with this equation right here. I don't need to look at the top one anymore. Okay, so remember, I need to set up a compound inequality with the solution between my positive and negative. So I'm going to write it like this. 4x plus 1 is less than or equal to 3. And then I'm going to put greater than or equal to on the left side. And it's going to be the negative version, which is negative 3. So now we can solve. What's the first thing I need to do? Subtract 1 from everything. What's negative 3 minus 1? That's negative 4. Less than or equal to. It's canceled. So 4x less than or equal to. What is 3 minus 1? That's 2. All right, and next I need to divide everything by 4 to get x by itself. All right, I'm going to bring this over here. But that's going to leave me with, what's negative 4 divided by 4? That's negative 1. Then we've got less than or equal to. Cancel out the 4. That's x. And then less than or equal to. What is 2 divided by 4? That's 1/2. And so my answer is right here. Negative 1 is less than or equal to x, which is less than or equal to 1/2. So let's graph this. So here, let's put the 0 right here. And we've got negative 1. So that's going to be negative 1 right here. And then let's just put 1 right here. Okay, let's look at the signs to let us know what kind of dot we should use. We can see that this one is less than or equal to. That's going to be a solid dot, so right here on the negative 1. And then where's 1/2? That's 1/2 of the way between 0 and 1, which means we're going to put our dot halfway in between. And it's a solid circle because you can see the equal to sign right there. And we need to shade for our solution. This is a less than problem, which means it's and, so we're shading in between. And that would be my answer. All right, let's do one more example with the less than. Okay, so first of all, we need to rewrite this equation with just the absolute value on the left side. So what do we need to do? Let's add 3 to both sides, plus 3 plus 3. That's going to leave me with 1/2 times the absolute value of 2w minus 1 is less than or equal to 1 plus 3 is 4. Okay, I want to get rid of this 1/2. How can I get rid of something being multiplied by 1/2? I can multiply it by 2. So I'm going to multiply both sides by 2. Okay, so boom. That leaves me with absolute value of 2w minus 1 is less than or equal to, what is 4 times 2? That's going to be 8. All right, and now we're ready to start working. So with the absolute value of 2w minus 1 is less than or equal to 8. We're going to write our compound inequality with our solution in the middle. So let's go with 2w minus 1 is less than or equal to 8. And then we're going to put greater than or equal to. And on the left side, we're putting negative 8. All right, so let's work this out. we need to get w by itself. So let's add 1 to both sides. All right, what's negative 8 plus 1? That's negative 7. Less than or equal to 2w. And that's less than or equal to 8 plus 1, which is 9. And then finally, I just need to divide by 2. Ooh. And we can see these are going to leave my answers in fractions. So over here, I've got negative 7 over 2, which is less than or equal to w, which is less than or equal to 9 over 2. So you might be able to see this in decimals, but we can leave it as a fraction. So let's put 0 on the number line right here. And then we've got negative 1, negative 2, negative 3, negative 4. And on this side over here, we've got 1, 2, 3, 4, and 5. Negative 7 halves is going to be halfway between negative 3 and 4. And what symbol do we use? We're going to use a solid circle because it's equal to. So right here, boom. And then where about 9 halves? 9 halves is halfway between 4 and 5. And what type of circle should we use? A solid circle. That includes the point 9 over 2. And now to shade for our answer, we're going to shade in between. Because our answer needs to be greater than negative 7 over 2 and less than or equal to 9 over 2. So that's it right there. Okay, so we just did some examples of less than inequalities, but what about when we have something that is more than? For example, absolute value of x is more than p. Absolute value of x is more than p means that x is more than p units away from 0. So once again, if I have 0 right here, and let's say I have p units like right here, and p units right here, positive p would be right there, and we'd be negative p over here. Okay, and greater than, so we're going to just use circles like this. Okay, it's more than p units away from 0. So should I be shading in between here? No! Because this is less than p units away. If it's more than p units away, it's going to be on the outside. So it would be like this. Over here could be my possible answers, and over here could be my possible answers. Those spaces, those numbers are all more than p units away from 0. So let's write an inequality that shows this. So this time we can see that my answers are going to be x is less than negative p, or my answers are x is greater than positive p. If we wanted to write this in words, x is less than negative p, or x is greater than p. To solve a more than or greater than absolute value inequality, we're going to rewrite the inequality as two separate inequalities. Remember, my two inequalities just there at the top, I had x is less than negative p and x is greater than p. So there's no way we can put x in between these two values because it's an or. So we're going to write two separate inequalities. Watch this. One of my equations is going to be 4x minus 3 is greater than 9. That's exactly how it appeared right there. My other equation is going to be 4x minus 3 is less than, I switched the sign, negative 9. And I did the negative version. And now we just solve from here. So let's see. We're going to add 3 to both sides. Plus 3 plus 3. That leaves me with 4x is greater than 9 plus 3 is 12. And then we divide by 4 to get x by itself. And we can see that x is greater than 3. For our other equation over here, add 3 to both sides. That leaves me with 4x is less than negative 9 plus 3 is negative 6. Then divide by 4. And that leaves me with x is less than negative 3 halves. So now we need to graph. Remember, this one is greater than, and we're talking about an or situation, which means we're shading on the outside, not in between our 2 points. So let's take a look at our 2 points. One we've got at 3. However, so let's just put the 0 and then 1, 2, 3. And what sign should we use? Should we use an open circle or a solid circle, closed circle? We don't see an equal sign, so it's going to be an open circle at 3. 1, 2, 3. That's right here. Let's label 0, 1, 2, and 3. All right, and negative 3 over 2 is going to be negative 1, negative 2. Negative 3 over 2 is halfway between negative 1 and 2. So I'm going to put an open circle right here and label it as negative 3 over 2. We use the open circle because it's less than. We don't see an equal sign here. And now where are we going to shade? Less than negative 3 halves would be this way. And greater than 3 would be this way. And that would be my answer. So notice on the greater than inequalities, we're shading on the outside of the 2 points that we labeled. All right, example 3. Let's go ahead and write our 2 equations. One of my equations is going to be just as is. 2x plus 4 is greater than or equal to 6. What's my other equation going to be? It's going to be 2x plus 4 is less than or equal to, I switch the direction of the sign, and negative 6. I put the negative version. And let's solve. We're going to subtract 4 from both sides. That leaves me with 2x is greater than or equal to 6 minus 4 is 2. Then divide by 2. And that leaves me with x is greater than or equal to 1. On the other side over here, minus 4 from both sides. That means 2x is less than or equal to negative 6 minus 4 is negative 10. And then divide both sides by 2. And x is less than or equal to negative 5. So now let's graph. We can see that we're using greater than or equal to and less than or equal to. So our solid circles is going to be what we use. So let's put our numbers 0 right here, negative 1, negative 2, negative 3, negative 4, and negative 5 is one of my points, negative 5. And then in the other direction, we've got just 1, and that's my point right there. So where are we going to shade? X is greater than or equal to 1, that's over here on this side, on the outside. And x is less than or equal to negative 5, that's over here. Greater than equations, we're shading on the outside of our points because it's an or statement. Okay, we need to take a look at some special cases though. Just like we had extraneous solutions when we were solving absolute value equations, we can have some special solutions here as well. So look at example 4. What do we need to do first here? We can't do anything until we get the absolute value by itself. So let's subtract 10 from both sides. Okay, that's boom, like that. An absolute value of 2x is less than 6 minus 10 is negative 4. Wait a second though. Look what this says. This says that the absolute value of 2x is less than negative 4. Any absolute value is going to come out what? Positive. So how can I put an x value in here that would make my absolute value come out less than negative 4? Any absolute value number is going to be greater than 0 because it's not going to be negative, it's going to be positive. So do we actually have a solution here? No, we don't. We cannot have an absolute value that's going to be less than a negative number because absolute value is always going to be a positive number, which is always greater than any negative number. All right, and now let's look at number 5. What do we need to do first here? The same thing, subtract 10 from both sides. That leaves me with absolute value of 2x is greater than negative 6 because 4 minus 10 is negative 6. But wait a second here. This says that the absolute value of 2x is greater than negative 6. But wait a second. Any absolute value number, no matter what number I pick for x, is going to come out positive, right? So if this side is positive no matter what x I choose, that's always going to be greater than a negative 6. It's always going to be greater than any negative number. So does it matter what number I choose for x? No, it doesn't. So in this case, my solution is all real numbers, which is this symbol. All real numbers. No matter what number I choose for x, it's always going to come out positive, which is always greater than a negative number. So these are 2 special situations to look out for. When you have absolute value of something is less than a negative number, that's no solution. And when you have absolute value of something is greater than a negative number, absolute value of something is greater than a negative number, that's going to be all real numbers. And for our final 2 examples, we're just going to translate some word problems into equations, inequalities. So read this one. Two friends are hiking in Death Valley. That doesn't sound fun. Their elevation ranges from 228 feet below sea level at Badwater to 690 feet above sea level at Zabriskie Point. Let E represent their elevation and write an inequality. So the lowest point that they're at is negative 228 feet because that's below sea level, right? And so that's less than or equal to because they're actually at the negative 228 feet point. So E represents their elevation. And what's the highest point that they're at? 690 feet. So that means they must be less than or equal to the maximum sea level point, which is 690. And that's the answer. You don't have to solve this. They're just asking for you to write an inequality. And then looking at number 7, a carpenter is using a lathe or something to shape the final leg of a table. In order for the leg to fit, though, it must be 160 millimeters wide, allowing for a margin of error of 2 millimeters. Write an absolute value inequality. Well, this is just like when we wrote an absolute value equation when we had the center and then the distance. What's the center? In this case, it's going to be what we need. Our target is 160. So remember, our formula is x minus the center. Our center is 160, absolute value. And then we see this key word right here, margin of error. That means they're allowing us up to 2 millimeters of mistake. So my mistake or my distance from my target can be up to 2. So it's going to be up to 2. And that includes 2 millimeters, so we're going to put less than or equal to 2. All right, so if you want to think about it, center or the target is 160. And then my distance or margin of error is 2 millimeters. And then we just had to understand that allowing for a margin of error means less than or equal to. We don't need to solve it. They just asked us to write an absolute value inequality, and this is what you would write. That concludes our notes for absolute value inequalities. So that is it. See you in the next one. Peace!